Okay, we begin this video with a few definitions. A set of ordered pairs x, y is called a relation in x and y. And the set of x values in the ordered pair is called the domain of the relation. And the set of y values in the ordered pair is called the range of the relation. Now, relation may be a new word for you. You're used to using the word function because everything usually passes the vertical line test. But if something does not pass the vertical line test, then it is called a relation instead. And this is a little bit more generic of a term. Now we move on to defining a function. Given a relation in x and y, we say that y is a function of x if for each value of x in the domain there is exactly one value of y in the range. That right there just describes the vertical line test. Write a set of ordered pairs, x, y, that define the relation. Basically, they just want us here to list out the 5 points in set notation. We have -2, 2 at the top left, comma, -1, 0, comma, 0, comma, -2, 1, 0, and finally 1, 2. That is the relation. To find the domain of the relation, we look at all the x values, noting that there's a couple repeat x values there with a 1, which we will only write once. And so the domain here will be the set of x values, -2, -1, 0, and 1. For the range, we look at the y values, 2, 0, -2, 0, and 2, and we see that 0 is a repeat value, which we will not list twice. And so we have -2, 0, and 2 as values, and by the way, 2 repeated also. Determine if the relation defines y as a function of x. Well, first off, if we go back to the graph, we notice that it fails the vertical line test, so we know right off the bat it is not a function from a visual analysis. We also can say, using our definition up above, that the answer is no, and because x equals 1, that x value, let me straighten that out, is assigned to both y equals 0 and y equals 2, and it is supposed to be a unique assignment. We now apply the vertical line test to determine if these graphs are functions, and in this first graph we notice that a vertical line can hit in 3 places, so no, this is not a function. In this second graph, the areas of concern are where these steps are joining. Notice each time I passed my vertical line through, it hit a solid dot and an open circle, meaning we did not pass through 2 points at one time. Therefore, yes, this is the graph of a function. And this graph is actually called a step function. Is this a function? Yes, it is. Each x value only has one assigned y value to it. It doesn't matter that it's the same y value at all. We now turn our attention to some notation. G of 3 basically means substitute 3 in as an x value as if this were an xy chart. So G of 3 is equal to 1 over 3, or 1/3. If we're substituting in a letter like f of a, that basically just means change the x's into a's. In this case, we get a squared plus 3a. To find the x and y-intercepts, we first need to substitute in 0 for the other variable. Let's start with the x-intercepts. We're going to let y equal 0, and this s of x is equal to the y, so we will have 0 equals the absolute value of x plus 3. And when we remove the absolute values, we get plus or minus 0, which doesn't mean much. So 0 equals x plus 3, and x is equal to -3. So the x-intercept is at -3, 0. To find the y-intercepts, we are going to let x equal 0. That means we're going to have y equals absolute value of 0 plus 3. When we evaluate here, we get y is equal to 3, and therefore the y-intercept is at 0, 3.